Okay, good afternoon. Welcome back. In this video, we're going to be tackling area of a sector and arc length. For the problems, you're going to see me work with the formulas that require radians. Even if the angle is given to me in degrees, I'm going to personally convert it to radians. There are formulas that use degrees, so moving forward, it's going to be your decision. But just a heads up, I'm going to work with radians. So, number one, in the circle shown below, there's a radius of 20 inches. To the nearest tenth of an inch, determine the length of the arc. And then we have an angle of 143 inches. Degrees. So that's actually the first thing. Since I'm given an angle in degrees, before I even start trying to solve the question, I need to convert theta. I want it in radians. So you take your angle 143 degrees, and we're going to multiply it by pi over 180. Oh, and you know what? Let me write theta equals. Okay. Theta equals. You can always put an invisible 1 underneath your angle. That way you can multiply straight across. This is going to be 143 pi divided by 180. Degrees cancel each other out. And it's always best practice to reduce this as much as possible by hand. But in this case, we're not going to be able to do it. So you can take your calculator and just get a decimal out of this. 143 pi divided by 180. That gives 2.496 radians. All right? So that's what I need to use. Now, the actual question. Determine the length of the arc. Hopefully, you're automatically saying, oh, I'm supposed to use the arc length formula because S equals R times theta. And remember, theta must be in radians. So the arc length S equals the radius, 20, times theta, 2.496. Now, even though I'm only writing 2.496, when I plug it into my calculator, I'm actually going to use the whole decimal. I'm just going to copy and paste the decimal. So that's going to be 49.916. But the problem wants me to do the answer to the nearest tenth of an inch. So the arc length is 49.9 inches. Okay. Number two. So once again, we have circle O. And this tells me that there's an arc length of 6. So I'm just going to make a note of it right here. S equals 6. We have an angle of 113 degrees. Find the length of the radius. So R is the mystery number that we're looking for. To the nearest tenth of an inch. Okay. So just like in the previous problem, I'm given an angle in degrees. I'm going to convert it to a radian angle. So theta equals 113 degrees times pi over 180. That's always the conversion when you're going to radians. So theta equals 113 pi divided by 180. The degrees cancel each other out. And once again, there's no common factor that I can use to reduce the fraction. So just going to go ahead and plug it into the calculator. And that gives me 1.972 radians. Okay, now for the main problem. Since we're given the arc length, the angle, and we're looking for the radius, I know automatically that we should be using our arc length formula. But it's a little bit different now since I'm given the arc length, 6. Okay. My first step is to write the formula. My second step is to plug in the numbers in the correct spots where they go. And now I can just simply divide by 1.972. Be really careful though. When I go to my calculator, I'm gonna divide by the entire decimal by copying and pasting it. So that gives me 3.042 as my radius. Oh, but it needs to be to the nearest tenth. So that's gonna be 3.0 actually. 3.0. Or you could just say 3 inches. All right. We didn't get an area problem in these examples, but it's a very similar procedure. We just have to use a different formula, which hopefully you guys remember. It's A equals 1/2 r squared theta, but theta has to be in radians as well. All right. If you guys feel like you need some examples for this, let me know, and I'll make a video giving you some support. All right. Thank you. I'll see you guys next time for Unit Circle.